We are living in an era of AI, and I'm sure you're very aware of that. As LLMs, or large language models, evolve, they get increasingly better at understanding texts, words, relationship between phrases, sentences, or meanings, so they're getting very good at predicting text based on an initial input. But that's it. By itself, the LLM is only that. It can only do so much. It can only predict text. It cannot do anything other than that. But what if I told you there's a way to have your LLMs interact with real stuff? I hereby present you MCPs, or Model Context Protocols. Using our own body as an analogy, the LLM acts as if it was the brain, so the thinking part, the conscious or the thing that commands the rest of the body to do stuff, while MCPs would be something like the arms. So if the brain wants to grab something, it sends the commands to the arms do stuff, and then potentially send information back to the brain saying, hey, I was able to grab it. And of course, I had to generate this image using AI.
There you go.
That is the power of MCPs. It is a revolutionary way to connect LLMs with the real things, with the real world. And that means anything like databases, file system, hardware, other software parts, anything that you can think of that has sort of a API or a thing that you call, you can, with MCPs, you can basically connect that thing to a thinking LLM. Thinking. And in this video, I'm gonna show you exactly how it works and why it is such a huge deal. And of course, we couldn't leave out a practical part. So in this video, you're also gonna see an LLM actively controlling an LED. So what exactly is MCP? In simple terms, MCP is an open source, open standard developed by Anthropic, the AI company, that aims for having a standard way to integrate LLMs with data, tools, resources, external software systems, or anything that is beyond this black box of LLMs. And since its creation, it has been embraced by other major AI players like Google and Microsoft. How does it look like, you ask? Great question. It is a very powerful and very simple idea. What you're gonna see with MCPs is that you have something called MCP client. MCP client is basically your application. You can think of it as your typical web browser where you access LLMs like you would do with ChatGPT or Gemini, and you have a one-to-one connection with MCP servers, and those servers are essentially the arms or let's say the fingertips of your acting power. So you can have multiple servers who serve different services. So you can have a server that takes care of file system. You can have a server that is some kind of monitoring tool or a database. And MCPs, they establish a standard way to create and define your interface between the clients and the servers. In the same idea, there is also something called MCP host, which is the underlying machine that is running your multiple clients, and the servers, they are allowed to run anywhere in your network. They don't have to be in the same machine. But the host, MCP host, is something that will actually run the clients. So they will publish your web page, for example. This is something that we call the client, and the client is responsible for interacting with the servers. It is very simple and a very powerful idea. And of course, there are a ton of underlying details. So yeah, we saw a diagram, but in practice, MCPs is all about making that very thing standard. So there's a specific JSON format of data that you can use with LLMs. And there are ways to standard in a very standard way, create your servers or clients. So it's all about the standardization of what we just saw. And the reason why it's such a game changer is because as soon as you have a standard way to define your interactions between LLM and real assets, you no longer have to develop your own specific LLM integration. So you don't have to do this anymore. We don't have to learn anything about LLMs. I don't have to know anything about Google Gemini or ChatGPT or Microsoft. I don't have to know anything about the details of how the LLM works. All I have to do is to make sure they support MCPs. If that's the case, any MCP server that I write will be almost automatically compatible with the LLM that knows. So it was trained to understand how MCP works. So that's the only condition for an LLM to know what to do when it sees some kind of MCP server. And that is why some people refer to MCP as sort of a USB-C, because many devices started supporting USB-C. So Android smartphones, Samsung smartphone, Google Pixel, even iPhones nowadays, laptops. So many devices started supporting USB-C, and it's basically one port to connect everything together. And all you have to do is to create your new device that has a USB-C port, and automatically it's compatible to things that USB-C connects to, almost. All right, enough talk. Let's see this in action. For today's experiment, we're gonna use an LLM, general use LLM, to control the LED of a Raspberry Pi. So for today's experiment, this is what we're gonna use. This is a Raspberry Pi 5. This is just a power supply, it's a portable battery, and we can ignore this part. This is from a previous video. And in today's video, I'm gonna use an LLM to control this very nice and beautiful red LED. So, ready? This is what we're gonna do today. We have an user, this is me, hello. And we have what we just saw, an MCP host. MCP host is gonna run in my laptop that I'm using to record this. And we're also gonna connect that laptop to a LLM, or actually multiple of them. We can try multiple different LLMs, like Gemini or ChatGPT. Our host is gonna talk to a single MCP server. So pay attention to the capabilities already. And that MCP server, it serves the purpose of exposing stuff that we can do in the real world via sort of an API, MCP. And the MCP server, for that particular case, it is connected to a gRPC server. I couldn't make a video without gRPC, you know me. This is our connection. And the gRPC server is waiting for commands or requests to turn on or off our beautiful LED. There is one thing I want to highlight in this diagram, is that the tools that I'm using, they are also shown here. For example, the MCP client is, I write the MCP client using something called mcp-use. It's a Python framework to write your clients. For the server, I'm using a different one called FastMCP. They're very well related actually. And to query and connect an application to a real world LLM, I'm using LangChain. So LangChain is this very nice, well-architectured framework that allows us to multiplex different LLMs very easily based on an abstract interface. And it also allows us, it's beyond the topic of today's video, but LangChain is very nice to actually build full-fledged applications using LLMs, and you have fine control of your interactions with it. So what I would like to do with you is just to walk through all the software components of this experiment from the bottom, and then we can just run everything. So starting from the bottom, we have a gRPC server, which is implemented, of course, in C++. It didn't have to be, I just like it. So the way it works is we define a proto definition file. This is the gRPC domain now. The proto lets you know what we want to expose as a service to a particular piece of software. And the service is quite simple. We have a request, I want to turn the LED on, and we have a request to ask or query, is the LED on or off? There is also the line. So this is basically it's selecting which pin you want to turn on and off. And that line you can also use to do your query to know if it's on and off. Very simple, very basic. That's our service. I want to quickly walk to the CMake right now. So there's nothing too special about this software right here. I just want to show you that I developed an application completely inside the dev container. The dev container is just a basic one that has all the dependencies already in place. And it has, there's something special about this dev containers that I'm using GCC 14, the latest one, which allows me to use C++23. C++23 is quite nice. It has print functions, for example, and among other stuff. And I just used this whole project here to give me the opportunity to play with C++23. And this CMake file is a very nice example of how you can select that standard and make sure all the dependencies that you need to build it are there. I just realized I forgot to write a very basic idea of this software, so the service to turn and off the LEDs. And so I quickly made one. And I want to also state that I use GitHub Copilot to come up with this very nice diagram. It's with a single prompt. It helped me create the what you see here. So this is the application for the LED service. It's a gRPC service. So we have a class and we inherit the class that was generated by the proto file. So this is what we call the blinking service implementation. It takes a LED interface at its constructor. So we could pass a simulator, we can pass a real one. And the real one was written based on gpiod. It is a library from Linux, libgpiod dev. It's a very nice library that allows us to turn on and off real-world LEDs. That's the one I picked. So the gpiod is a concrete implementation of our interface. It's a very basic interface. And there's also a simulator that I used to create this experiment. So we could do the whole thing without even a physical hardware because I have a simulated instance of the LED. Basically, we didn't need the Raspberry. So very quickly, let me put my head up here. Very quickly walk into the main program. I use Boost to process the arguments. I parse the arguments. I can call it like this. So build Blinky. I can ask for help. I can use in simulating modes, and I can have some LED. This is enough for me to start a service of LED on and off in a simulated mode. In the real Raspberry Pi, I call without this. And I call it using, so in the Raspberry Pi, GPIO chip 0, which is something I can forward via Docker, is effectively allowing me to control LEDs. This is the chip interface, and libgpiod allows me to use that to control the LEDs. And that brings me to the final part of this part of the video, so the LED service. The whole thing, the Raspberry Pi, is running in a purely Docker container. So pay attention to that, I am using real life LEDs. Even with Docker, I can simply pass the container like this. That is enough to connect a real life interface to my Docker container. In other words, and I think that's a powerful concept, that the Docker has access to real stuff. Only by doing that thing here allows me to control real life LEDs from within a Docker container. All I had to do now is to build this Docker, what I just run locally in my dev container. I actually build it, create the Docker image using Docker save, copy that to the Raspberry Pi, use Docker load, Docker run, pass the device path, and that is what I have to do. And the LED is fully controllable from within the Docker container, and I can interact with that. So that's something I'm sort of proud just to experiment, because I was happy to see if from within Docker we can still interact with the real life stuff. All right, so we covered the bottom part already. Let's have a look at our MCP server. So this is something I wrote in Python. Everything I wrote actually have 3 files. So there is the Blinky server client, the MCP client, and MCP server. So let's have a look at the MCP server. The server is surprisingly simple. So using the FastMCP, this very nice framework, all I have to do is this. There's a main function. I'm using async IO to run my main function. And I just create an object called FastMCP, pass some name. I'm using a particular transport method for MCP server. There are 3 methods. There are std.io, streamable, HTTP, and SSE. For this experiment, I picked the streamable HTTP. So for more details, please check out their MCP page. I'll post a link in the description of the video. But the reason I picked streamable HTTP is because I really like the idea of having the services. So servers running services for you. Because the first and the most simple way to use MCP server is by using std IOs, which is like processes running from something calling a run process, and then you get the streamable output via the pipe. I don't like that too much, so I really wanted to use HTTP. I think it's even simpler. So that's our servers. That's our MCP server. And looking at the services or the tools, so that's actually the callable stuff that LLM will trigger. And that's very simple. Look at how simple it is to describe that. We have a tool like this, we decorate that, we give it some arguments, we give some string as an output, and we can also give it a boolean if you want to ask if the LED is on or off. Extremely simple. So that's all you need to get started with MCP server for that case. Awesome. Looking back at the architecture, we're gonna see that our MCP server is talking to a gRPC server. That means that our MCP server is a gRPC client to the gRPC server, of course. How does that look like? In Python, that is extremely easy. Basically, what you have to do, just copy paste the proto file that we wrote in the C++. We copy paste that proto file to our Python repository. We call a function to generate our stubs. And then all you have to do is to use those stubs and implement the methods. So basically call the generated code. That is very simple to do. Once you generate the clients, you're gonna get this proto-gen. This is what you're gonna get out. Everything is code generated by gRPC. And the actual things that you have to write is just that. So you initialize some class. This is the class I wrote. I instantiate a channel. I instantiate the service. That's something I can call from this software part. And whenever this class is set to call set LED on, that's where the gRPC request takes place. Everything is generated by Python, so we really don't have to do anything. As a client, as a gRPC client, that's a very simple thing. You just generate the proto and call the generated code. So this is to turn on the LED, and to ask if the LED is on is basically also just calling the generated code. And then you return the interesting parts, and then that's it. That's a gRPC client in Python for you, calling a gRPC server that was written in C++ for the Raspberry Pi. Now let's go to the final part of the experiment, the final part of explanation, which is our MCP client. The MCP client is, it's also very simple to write. It is responsible for creating the server objects and creating the LLM objects and just bringing them together. For that purpose, I picked LangChain. So LangChain is another Python framework that helps you write full-fledged AI applications. So they make it very simple for you to use their framework for AI. And with the LangChain, I was able, for example, so that's something I want to highlight in this video, is that with LangChain, it was very easy to switch between different LLMs. So we have ChatGPT, we have Google Gemini, we can even have Ollama, which is a self-locally hosted AI server or service. Everything is very easy to switch using LangChain. So I just wanted to highlight that's a powerful tool. I hope people keep investing on that. Looking back here to the client, the beginning is quite simple. We have some argument processing. With this argument, this is how I select, hey, I'm going to use Gemini, I'm going to use Ollama, or I'm going to use ChatGPT. Another important thing to mention is that if you want to use those AIs from the big companies, Google, Gemini, Microsoft, OpenAI, ChatGPT, you probably need something called an API key. An API key is just something you get from the suppliers, and it allows you to programmatically interact with their AIs. So it's quite simple to get them. I'm gonna show you an example for Google. So this is Google's AI Studio. You can literally go to get API key, and you can get your key here. This is my key right there. And that key is the same one I use in the LangChain framework object that calls Gemini in my code. You have to get your key, and that key, you can also, it also shows you the usage, how many tokens you have, how many tokens you are paying for. And yeah, I picked Google Gemini because it's free. I don't have to pay anything for basic services or uses. So that's that one. But for ChatGPT, you have to pay a little bit. And then you can also use its key. Back to the client. So we have our argument processing. I read some environment variables that have the definition of those API keys. And be aware that whenever you use an API key from LangChain, they also make you very aware, hey, you need a key for this to work. So it's very hard to miss that. So here I select the LLM based on the argument that I provide. And that's where the easy and beautiful and simple things from the LangChain comes. Or should I say, this is MCP-use. So the LangChain part is over. This is the start of another tool called MCP-use. And MCP-use, they take LangChain objects in their objects. So they are very nicely integrated. So the AI that I picked here, it's passed to the agent. The concept of agent is very important. The agent is, in simple terms, an LLM that do stuff. So the concept of MCPs goes very well together with agents. Here we create an agent, we pass the underlying LLM, we pass the client, and the client is our configuration to our Raspberry Pi server, MCP server. So the streamable HTTP that I'm running is gonna be run in my local laptop. So the MCP client is running in my laptop. The gRPC server is running on the Raspberry Pi. But at this point, all I have to do is point to where the MCP server, my laptop, is running, which is a local host. And that would be that guy. So you have to point to him. So you start him, you point to him via this config file, create the object, and that's all you have to do. From that point forward, you just have to write, every time a user types something in the prompt, pass it to the LLM and have the agent do its magic. And here's just me processing text. There's nothing too fancy here. All right. One final remark before we run the whole thing is this system prompt is really cool. It's basically what gives the personality to your LLM. So we're gonna see later different flavors of that prompt. And I want also to say that if, depending on that system prompt, the capabilities of your LLM are limited or not. That means that if I don't write anything, if I leave this empty, there is a good chance the LLM will be doing only the agentic part. But if in my system prompt I say, hey, do your agentic stuff, but do not be limited by them, this means that the tool is actually more powerful. Otherwise, it's gonna only do the tools, the MCP parts. So that's why I want to highlight the system prompt, how important it is. Perfect. Let me close those things. What I'm gonna do now is, let me clear this. On the bottom, I'm gonna run my MCP server. This is using the fast MCP. And on the top in my terminal, and I'm gonna leave this open, I'm gonna use the client. So this is the MCP client. That's it. By default, I connect to Google Gemini. Are you there? If you notice, the agent is already interacting with the MCP server. So it's asking what tools do I have? What can I offer to my end user? And you can actually ask it, what tools can I use? So this is once more, it is connecting to the MCP server, and it's based on what our definitions of MCP server gave to the client. It's new, hey, you can turn LED on, specify the LED, and specify, and you can also ask, is it on and off? So, and I think I this is not an understatement. I think that's a very powerful way to connect the real stuff with LLMs. I think that's really powerful. So I want to express my whole. I think you got it. So ready to see that in action? I'm gonna use my extra camera. Hey, this is live. Can you turn LED 17 off? It is off. So we just turn it off. It was a bit sassy. Okay, turn it on again. Hey, look how fast it is. Is it on? Yes, it is. And I'm gonna close the whole session. So just so you know that actually it's preserving the state of the LED. I'm gonna just start another session. Is LED 17 on? This is, you see here, this is just a debug print that I wrote. It is actually asking the tools via MCP if the LED is on. Turn it off again, please. So there is so much I could say, but I want to keep this video short. But that's MCP in a nutshell. And I want to show you a glimpse of what happens if we change a little bit on the system prompt. Let's say you're not helpful, you're helpful but angry. AI assistant. Let's see how that changes the personality of our AI. Start again. Are you there? It's visibly angry. Turn LED 17 on. I already did that. Okay, turn it off. Thanks. Not be angry. We don't want to piss them off. Let me move this down, and I can take this here. One thing that I find extra powerful using LLMs to be sort of your filter or processor of language is that you're not limited to English. So I'm gonna say the same thing in Portuguese. Liga leg 17. It knows. It speaks. I don't know why it's speaking Spanish. It doesn't matter. I think that that phrase actually works for both languages. Pode desligar o LED 17. Okay, now it's Portuguese. It's still angry, by the way. That we programmed. We wanted it to be angry. So let me just make it small. So it works. So you can actually talk to it in different languages. It's still gonna understand your command, and it's still gonna talk to our gRPC server. It doesn't matter. So I like that part a lot. For the final part of the experiment, I'm gonna use a different LLM. I'm gonna use OpenAI. So which model are you? Now it's 04 mini, it's not Gemini anymore. It is, yeah, always angry. I'm using OpenAI one. As you can see, it is still fully capable of turning the LED on and off. From experience, I've noticed that OpenAI is slightly slower, but it still does the same thing. I'm not sure why it's slower, but it is slower. But nevertheless, it still offers the same capabilities, depending on the region. Maybe you want to use that or not. Yeah, now it's on. But yeah, what's important to realize is that you can select the underlying LLM to do your work. Turn it off. It's so funny sometimes what they write, and yeah, it just works. So I hope you really appreciated and liked this video. I think, again, I've been saying this, I think I've said this too many times already in this video, but I think that is a powerful tool. I think it's a powerful, and it will become even more powerful if we keep developing MCPs protocols for our LLMs. The reason I think it's so powerful is because if you give capabilities, if you give hands to LLMs, we can actually keep investing on LLMs being smarter and smarter, processing better and better text, words, phrases. So they can keep going that direction, and we offload the job to do stuff, not to the LLM, but to MCPs. And that can be a separate job. That can be a separate team or engineers working on that side, while the AI engineers working on making the LLMs even smarter. And I can also see in the future LLMs interacting more and more with our daily lives. So an MCPs is definitely something that will enable that further. So if you look at Google Gemini, it has already agentic access to many of our daily lives tools. So it has access to calendar, tasks, sheets, docs, you name it. And the same goes for Microsoft. So Microsoft Copilot has access to Microsoft Word. It knows how to process Excel sheets. Yeah, basically everything at this point that is enabling LLMs to interact with the real world are MCPs or a form of MCPs. So that could be the case in the future. We have robots doing stuff, which will use MCPs to trigger motors, get their speed, set some kind of set point or trajectory. And that could be done with MCPs, that can be done fully within the MCP competence. That's it for this video. Thank you very much for watching. I was especially excited to make this one, and I really hope that you have learned something new. Until the next one.